Most recent towed streamer marine is acquired for 3D surveys. So you might think that once XY coordinates are available, all that is needed is to define a 3D grid and start processing using 3D algorithms. Nope. There's often a lot of processing that occurs before any 3D algorithms. This processing might even be done on the seismic vessels themselves. This video tries to describe some techniques used for early processing. The main program focused on here is sunomstreamers, which also allows you to process some old marine surveys for which no coordinates are available at all. Near the end of this video, there is a section which indicates how one of the main techniques described herein might also be beneficial for 2D land. After that, I conclude with comments about some aspects of towed streamer marine which might be unknown to some seismic data processing people.
The scripts in demos Geom3D sunomstreamers also show how to produce some of the displays seen herein. I'm going to proceed in this order. Here is a simple diagram of a towed streamer situation. Usually there are a lot more streamers behind the boat, and the streamers are a lot longer. We'll see that later. Concentrating on the streamers, you must specify the inline offset at the start of the streamers, and the crossline offset of the streamers, and the channel spacing. Also, you need to specify which channels were recorded by the streamers. The channel start parameter is the channel at the forward end of the streamer, which is usually the end nearest the boat. Several confusing things about channel numbers occur quite often. The channel numbers may not end up in the trace key that you think they should. The default of sunomstreamers is the track F key, but you need to check that. Another confusing thing is that channel numbers may not be the same as receiver group numbers. This occurs because channels are defined by the seismic recording system, while receivers are actual pieces of hardware within the streamers. The main thing to note here is that some streamers have negative crossline offsets, while other streamers have positive crossline offsets. If you are lucky, your traces will have completely different channel ranges for each streamer. If you are not quite so lucky, you may still find that your traces contain a streamer identifier. If not, you will have to renumber your channels or create a channel identifier somehow. You also need to define the crossline and inline offsets of the air gun arrays. Crossline offsets on the other side of the boat need to have a different sign. Note that I am carefully avoiding saying that negative crossline offsets are on the port side of the boat and positive offsets are on the starboard side. Quite often, any sign convention is not well defined or followed. Now, we need to consider the distance between shots and which gun array actually fired. Of course, the actual shot spacing is determined by the boat speed and the time between shots. The nominal inline shot spacing is the value wanted here. Multiplying the shot spacing by the shot number gives a nominal inline position for the boat, and all the offsets and spacing that you specified are relative to that position. For port starboard shooting, the port air gun array fires, then the starboard. Assuming the shot number increments by 1, then the odd shot numbers will be from one air gun array, and the even shot numbers from the other air gun array. Parameter gun mod performs integer divide of the shot numbers and uses the remainder to identify the air gun arrays. In this situation, gun mod is set to 2, which means the remainder is either 0 or 1. You list the 0 and 1 in the gun ID parameter and the corresponding inline and crossline offsets in gun inline and gun cross parameters. It might be that your traces have an actual gun ID in some other key. That value might be called the source code or something like that. It might be in the SegY trace header somewhere. Okay, it is about time you get a look at the setup of sunomstreamers. In fact, here are two setups. The second setup does exactly what the first setup does. I blanked out the values in the second setup when the default supplies the same value as the first setup. The defaults assume that subsequent gun arrays have the same inline offset as the first gun array, and all subsequent streamers have the same inline offset as the first streamer. Also, the default assumption is that channels on subsequent streamers are numbered contiguously with the first streamer and have the same amount of channels. The keen observer will notice that there is no input specified in the sunomstreamer setups. The sunomstreamers program can output fake traces with trace key values computed from your specified parameters. It can also put spike amplitudes into the trace samples. Filtering those spikes and applying inverse move-out creates fake reflections. We'll see those later. Running either setup makes fake traces with these locations. About 30 years ago, when I first saw this kind of display, I remember being surprised that the midpoints form straight lines. For some reason, I expected them to be scattered or form. These are the two subsurface lines of traces received by the second streamer. Note that traces of the top subsurface line originated from the top shots, while traces of the bottom subsurface line originated from the bottom shots. In other words, one of these subsurface lines is from the port airgun array, and the other is from the starboard airgun array. Usually, the cross-line direction has less dense spatial sampling than the inline direction. This makes it difficult for 3D algorithms to produce good results. Therefore, it may be beneficial to separate the subsurface lines from each other and process them using 2D algorithms. Along with the nominal coordinates, the trace CDP can also be updated by sunomstreamers. Note that I say can be updated. You can choose not to update these keys, which often is required when you get into complicated data processing situations. So, you've gotten sunomstreamers set up nicely. Now what? The 5 main uses of sunomstreamers. If you actually have an old survey with no coordinates at all, then you can make some using sunomstreamers. When creating coordinates, sunomstreamers uses the x-coordinate for the inline direction and the y-coordinate for the cross-line direction. It also adds big constants to those coordinates to avoid negative values, since negative coordinates might cause problems in some programs or displays. The 3 main uses of sunomstreamers. These are discussed in detail. A look at the first 50 traces of the first shot of a survey with 11 streamers. Same image, except there is a red line across it to highlight that the middle streamers are closer to the air guns. We want to correct all traces so their source-receiver offset appears to increment by the channel spacing regardless of which streamer they are on and which air gun array fired. This employs a technique called Differential NMO or differential move-out correction. Differential NMO can be achieved by this sequence of programs. SU-NMO CSV applies full forward NMO correction from the true XY offset to 0 offset. sunomstreamers changes the offset key to the nominal inline offset value. SU-NMO CSV applies inverse NMO correction back to that nominal inline offset value. Now all streamers look the same, but more than that. Each streamer appears to have been recorded from a simple 2D acquisition with only one airgun array and one streamer. A few details of these setups. You should use a large stretch mute limit. Remember that this differential NMO is correcting the traces to 0 offset and then back to the nominal inline offset. You do not want to lose any seismic data while doing that. These programs can be used to separate the traces into subsurface lines. A simpler SU change header word computation can be set up. Just multiply the gun number by the streamer number. But the computation seen here results in subsurface line numbers that are sequential from one side of the boat to the other. The SU cleave program may be unfamiliar to you, but its function is quite simple. You might look at examples in Demos Geom 3D for SU cleave and also examples for program SU braid. After applying differential NMO, separating subsurface lines, and performing whatever data processing techniques you wanted, you can reverse the differential NMO by following the instructions here. You do not have to use just one velocity function for differential NMO, but quite often the purpose of differential NMO does not require great accuracy in velocities. The offset key is integer, therefore it cannot hold a value like 12.5. This may be a problem in some situations. But remember that nominal geometry is not actually true geometry. Nominal geometry is already an approximation, so sometimes you might want to use slightly different values for that approximation. Before concluding, I want to highlight some aspects of towed streamer marine that will not be familiar to land processors. A few shots with some feathering. The streamers often cover a total crossline distance of about 1 kilometer and have lengths of about 10 kilometers. So this image still has short streamers. More shots and the midpoints of just one CDP in black. A close-up of the midpoints of nominal CDP 1010 in all 22 subsurface lines. An even closer look at the midpoints of nominal CDP 1010 in all 22 subsurface lines. Back to the full display here, but now highlighting midpoints of CDP 1010 for just the outermost subsurface lines. A close-up. Comparing traces in nominal CDPs to 3D grid CDPs. Of course, nominal CDPs may not have traces that extend over the kind of area seen in the previous image. It depends on how much feathering there is. But comparing the spatial size of a 3D CDP to a nominal inline CDP is not really fair. Nominal inline CDPs are intended to have traces with a nice distribution of offsets and to have next CDPs and previous CDPs with similarly nice offset distributions. A data processing algorithm that requires nice offset distribution or consistencies between CDPs is much more likely to have it using nominal inline CDPs, especially when also using traces that have been corrected to nominal inline offsets via differential NMO. See my video about CDP profiles, crooked and straight, for more along this concept. You might consider using differential NMO in 2D land. The 3D grid program SU bin CSV can also compute inline nominal CDPs from station numbers. These station numbers can be found in standard SPS2 files and should exist in the traces if you have used SU Geom CSV program to update your traces with land geometry information. A few details about the computation of CDPs from stations. CDPs computed from stations have a lot in common with the nominal inline CDPs computed by SU sunomstreamers. You can also get a nominal inline offset from station numbers. The offset value is basically just the difference in stations between the shot and receiver multiplied by the station spacing. That allows you to perform differential NMO similarly to what is described in this video. For the rest of this video, I'm just going to highlight some differences between the early data processing flows of land and towed streamer marine. Shots are surface consistent, but receivers are not. The local ocean conditions at the air gun array are the same for all traces of a shot. But the local ocean conditions are different at each receiver of that shot. And for the next shot, the receivers have moved, and anyway, the ocean conditions have changed. In towed streamer marine, the receivers move during the recording. This means the top of the trace is not imaging the same physical location as the bottom. Since the receiver is moving at about 2 meters per second, this means the bottom of a typical marine trace is about 20 meters further along the sail line than the top of that trace. For towed streamer marine, both the shots and the receivers can have ghosts. These are mainly caused by the fact that both air gun arrays and streamers are just under the surface of the ocean, and therefore reflections from the underside of the ocean surface get recorded. Towed streamer coordinates can be wrong. Streamer positions are not just produced by GPS receivers. They also have pingers which are recorded by other nearby streamers and then processed by solvers which are similar to residual surface consistent static solvers. Needless to say, the derived receiver positions can suffer the same problem as statics. Generally, these problems result in kinky cables. Streamers make noise as they move, more noise if they turn or speed. No cross spreads. Deep water should get water velocity correction. The basic problem here is that ocean water will change temperature. So even if you come back to exactly the same coordinates, the time taken for a signal to go through the water changes at both the shot and the receiver. Most of the temperature change occurs near the surface, and below 1,000 meters the temperature is almost always near 2 degrees Celsius. But the near surface temperature change can result in 8 milliseconds or more time difference. And for deep water, it is not a static. The ray path angle associated with the offset distance causes the time differences to change for each trace.